I'm going to try to go through this study guide in about 10 minutes, just for those of you that didn't get to see me the last few days. So this is the study guide. You have the answer key, you have the study guide. I just wanted to make sure that those of you that would like a little bit of extra time to practice had that. So for number 1, we're talking about complex numbers. The negative sign means we're going to have an I. So square root of 16 is 4. The negative sign means we're going to have an I. Square root of 4 is 2. The negative sign means we're going to bring out an I. Add them like they're like terms. That is 6I. For this one, again, we're just going to add like terms. So distribute the negative sign. So we have 6 plus negative 1 plus 2. So that should be 7. And we have I plus 3I. So that will be plus 4I. Again, just add like terms. Scrolling down to C. C is a little bit harder. We're going to have to do order of operations. So multiply first, and then we're going to subtract. So if you multiply the first one, we'll get 2 times this minus 9I plus 6I minus 9I squared minus, and this is the difference of 2 squares, so we'll have 9 minus 4I squared. Before I distribute that negative sign, I want to take care of these I squared. Remember, I squared is negative 1. So this really is going to be plus 9, and this is really going to be plus 4. So 9 plus 6 is 15 minus 3I minus 9 plus 4 is 13. So we have 15 minus 13 is 2 minus 3I. Okay, number 2. Given this polynomial, state the vertex and whether or not it's a maximum or minimum. So this is a vertex from which you will be given. So the vertex, you change the sign of H, so that will be a positive 1, and you keep the sign of K. For whether or not it's a maximum or a minimum, that negative 4 tells me my parabola is going to be upside down, which means my vertex is going to be way up here. So it is going to be a maximum. The next one's a little bit harder because it is not in vertex form. So the first thing we're going to do is find the axis of symmetry, which is negative b over 2a, which is negative 12 over 2 times negative 2. So we have 12 over negative 4, which is 3. So we know the x part of our vertex is 3. So let's plug that 3 into our equation. Find y. So we'll have negative 2 times 3 squared minus 12 times 3 minus 16. So we will have negative 2 times 9 minus 36 minus 16. So we will have negative 18 minus 36 minus 16, which is a really ugly number. It's negative 70. To determine whether it's a maximum or a minimum, to determine, oh, this should have been a negative 3, shouldn't it? That is why that number is ugly. Negative 3, so this should be plus 36. I wish you guys would stop me. Just kidding. So this is not negative 70. So this is actually 18, negative, 36 minus 18 minus 16 is 2. which is a lot happier. Again, to determine whether or not it's a maximum or minimum, that negative sign out front tells me it's upside down, so we are going to have a maximum again. Next, convert this into general form. General form is given to you on your formulation. General form is ax squared plus bx plus c. So first thing we have to do is FOIL that stuff in parentheses. So that'll be x squared plus 2x plus 1 plus 2. Multiply before we subtract 2x squared minus 4x plus 4x plus 2 minus 2. These are like terms. So our answer is going to be 2x squared plus 4x. It does not say to factor my answer. It says to leave it in general form. So we have a 0c. So we're just going to leave it like that. For 5 and 6, your exponents, not your coefficients, your exponents cannot be decimals, fractions, negatives, or radicals. So this is not a polynomial because of this 2.2. This is a polynomial because we don't care that the coefficient is a radical. Okay. Oh, too far. Chug along, we're at 7. The degree is always the highest exponent. The leading coefficient is the number in front of that, so -2. The maximum number of terms is the degree minus 1. So that's 7. The end behavior. If our degree is even and our leading coefficient is negative, we look at that chart and both sides are going to go down. Number 8. Number 8 is worded harder than it actually is. If a polynomial is going to cross the x-axis, what has to be true about the exponent, the multiplicity? In order to cross the exponent, the multiplicity must be odd. Now, what must be true about the exponent if we're going to have both increase? Well, look at your chart. It's a different chart, but look at your chart. If we're going to have both increase, then n plus 2 must be even. What must be true about a, the number out front, if both increase? Well, if both of them are increasing like this, that means it's not flipped upside down. That means the number out in front must be positive. And state the multiplicity of x equals 4 when n equals 3. Well, if you look up top, it says x minus 4, and that's where x equals 4 happens here. So x equals 4 here. The multiplicity is this exponent. So if I substitute 3 in for n, so put 3 in for n, 3 plus 2 is 5. Again, that problem looks a lot harder than it really is. Divide using long division. Yes, you can check this using synthetic division, but you must divide it using long division. So x minus 3 divided by x cubed minus 2x squared by x plus. These are in order, so I am going to leave it there. But I also have to remember to look to make sure that these are going down 3, 2, 1, no x's. Otherwise, I might have to put in a 0x or a 0x squared. That is not true in this case, though. So what do you have to multiply by x to get x cubed? Well, that'll be x squared. I'm going to subtract x squared times x and x squared times negative 3x. So x cubed minus 3x squared. Distribute the negative sign. And it looks like this is going to continue in a second recording, but add down. This will be x squared minus 5x